Thank you. Thank you for the opportunity to share information that I am very passionate about. And I hope that this gets you to thinking creatively about the fire problem in the world. Please let me thank the Institute of Fire Engineers for all the work that you do around the world and the opportunities that you've given me to present today and in the past. A special thanks to the National Fire Chiefs Council for the work that you've done leading up to this point, and a special thanks also to the U.S. branch of the IFE and Chief Bruce Varner, who gave me this opportunity and has been a mentor and supporter for many years. Let's talk about fire protection systems, particularly water-based fire protection systems, and how they interact with modern construction and materials. I've spent many years of my career as a fire officer and as well in research and testing for advocacy in making changes to not only how we fight fire, but to how we protect buildings. I'd like to start off with the then and now. I have here from 1955 a chart as well as a current chart that shows that fire sprinkler systems have been 96% effective for 121 years. Now, since we've been tracking data in the National Fire Sprinkler Association with our partners in the International Fire Suppression Alliance, track the sprinkler shipments around the world and in the US. We do that for a basis of trying to maintain accurate data. We work with our partners at the National Fire Protection Association to also address the effectiveness. Now, I like to think that we're more than 96% effectiveness because this depends upon accurate reporting. Now, being from the US and making up your own facts in these days and times is not very popular. So I'll simply stick with the 96% that our association, who's been around for 105 years, have been documenting. But let's jump into the fact that the top cause then and the top cause now for any failure of a system is a closed valve, and that remains today. So I want to share with you a lot of history that we have, but I want to share with you modern incidents that we have in our industry. This is a fire that did cost someone their life and put many firefighters at risk. This was a NFPA, a fire sprinkler system installed in accordance with NFPA 13R. However, there was a valve closed. And in this particular incident, 8.5 hours after this fire, someone was rescued from the second floor of this building. So don't ever count out the occupant and make sure that all your processes are complete. However, know that there are areas that are not protected with fire suppression systems, and that can result in the spread of the fire. So outside of human interventions, this is a fire recently that also cost 3 people their lives. And even with an impeccable response of the fire department, there still wasn't enough time, and this was a lightning strike, and the fire originated in an area that was not protected by fire sprinklers. So as we track and as we try to maintain a count on the number of people who have perished in fires accurately, we also try to track the people who have perished in buildings that are protected with fire sprinklers. And while in the US that number averages 3,000, I believe in the past 2 years, according to our own information, that we have only lost 13 in buildings protected with fire sprinkler systems. And this happens to be another one where 4 people lost their lives. And I say that this is a lack of maintenance on the system in which it was a valve closed, as well as accountability as who is accountable for the outages should not occur after the fact. It should occur during a well-defined process. I'd also share with you that the same time that fire happened that cost 4 people their lives, a properly designed and installed, and if you maintain the system, there are no fatalities. And we like to say that fire sprinklers buy time and time buys life. Fire sprinklers buy the time for the occupants to escape and the firefighters to do their jobs and make the rescues. And I'll end today's presentation in showing you some research that shows the need for all these components to act within our buildings and structures because of the modern contents, the modern construction, the modern components, and the modern methods used in the construction. But don't let that modern fool you. Changes in our existing buildings to bring them up, the changes in the contents also cause us issues. And in this case, the fire sprinkler system in the attic was valved out, but the wet pipe system that protected the occupants gave them and the firefighters time to act. Delays in reporting have always hampered us and have always hampered us in our abilities to know and understand that there is a need for us, and there also is a need for the fact that we need time to even apply manual fire suppression, and that's what happened in this case. A delay, this building was occupied, but again, not all places included fire sprinklers. And so with that, the fire started, was witnessed fire, but a long delay in notifying the fire department. And with that, also the challenges faced with getting water to places that aren't protected with fire sprinklers is a challenge for firefighters. And with that, that caused the loss of the entire structure. Fortunately, no one lost their lives. Construction fires. So modern construction. This is a very difficult challenge for firefighters and a very difficult challenge for contractors as to how you maintain safety and protection. NFPA 241 gives us clear guidance as to how some of these things should be performed. However, when there is an unwanted fire in the facility, that presents a particular challenge. And in these cases, from early on in the construction process to nearly a complete structure, the challenge remains that firefighters are at risk in attempting to deal with fires in construction. This is an example where a construction fire meets existing facilities. As you will see, there is a construction zone and a construction site. Once that fire began in the unprotected areas, you'll notice the high-rise building in this picture. The high-rise building was occupied. The windows in that facility from the second floor all the way to the top floor were compromised, and the fire department, in supporting the fire protection systems in that building did not suffer fire damage to the interior. The fire sprinklers held the fire to kept it outside of the structure. 90% complete. This building was 90% complete, and one of the initial reactions of this fire is to turn the fire protection systems on as the floors are added. While that may sound like a simple approach, it is a very complex process. And while we need to understand the relationship between the fire protection contractor, the water purveyor, the alarm contractor, the authority having jurisdiction, and all the officials involved in making this scenario a more positive outcome, in some cases, the laws and regulations that govern different components of that construction sometimes hamper our abilities to maintain a safe environment. And with that, that is where we encourage active involvement to remove those obstacles and hurdles, but to bring all the stakeholders to the table in the process to understand everyone's side, because no one wants to have the tragedy that occurred here, which in this case just happened to be the loss of the facility, but it still put a lot of people in harm's way. This is another case where the building was under construction, was almost complete, and the fire department nearly had it maintained to the area that it started in a trash chute. However, unfortunately, it got into a space, again, not protected, the fire protection system's not turned on, and with that, the building caused firefighters to be put in harm's way that ultimately ended up in a $50 million total loss of the facility. Fatal construction fires. We see a lot of construction fires around the world, and with that, though, we very seldom see fatalities. However, in this case, the fire was so fast moving that 2 construction workers did lose their lives. And a lot of fire department resources were damaged. And again, initially, a lot of firefighters put at risk and throughout the duration of this incident. But those fires continue as we all continue to seek solutions because of the modern construction components, methods, but also don't forget, it's not just those things. Many times it is the relationship of the people involved in the process. Storage warehouse fires. I want to move on to the fact that the one thing that has changed in addition to the construction is the commodities and the configuration of the products that go through our buildings. And in these cases, you see warehouses. One particular warehouse cost the lives of 6 firefighters. The other, while it didn't cost any firefighters their lives, ended up in a $750 million loss, which includes a lot of jobs, a lot of tax revenue and resources to community as well. But they are always a burden on the environment and the community into which they occur. The key here is the fact that the commodities, as they change, so must the fire protection systems and how we deal with the commodities being put into these buildings. These fires continue to happen. The one thing that we would encourage is the fact that you do not shut the system down. The challenge that we face is the commodities as the fire sprinkler and fire suppression systems in the buildings attempt to control and contain this fire. It is simply doing that to the best of its ability until you as fire service get into the building and get it completely extinguished, as you well know. However, in many cases, we fail to recognize the change of the commodities, the change in the configuration of how those commodities are dealt with in the building. And as a result, if the fire sprinkler system becomes overwhelmed and you turn its water supply off, or anyone turns its water supply off, it further results in something that typically cannot be stopped. And we haven't witnessed many cases where it can be stopped, even with trying to put the rest of the systems in the building back into service. Scientific research. We've spent many years, and I've spent the last decade or more of my life involved in live fire burns, where we actually burn products, contents, and particularly, especially looking at homes in the change of the fire environment in those homes. And as a mentor of mine and a former fire chief in the Phoenix Fire Department here in the U.S. said, Chief Brunacini said, Shane, we're finally listening to the fire. And so I think that's what we've got to continue to do, is to continue to doing research. Shout out to Underwriters Laboratory, to Factory Mutual, to NFPA's Research Foundation, and to all of our labs and your efforts around the world to study fire and the modern components, contents, and configuration of these fires. This research is involved, and this is at Underwriters Laboratory, where they were conducting testing on firefighting strategy and tactics. We went ahead and added some research to that and said, let us see the difference with fire sprinklers and without fire sprinklers. And one of the things that we wanted to look at and consider was, what about the energy code coupled with the building code, in this case, the residential code, and all of the components and complexities that go with that. And this is a case where perhaps the fire code didn't consider the energy code and the many changes in the structures that we had. And so with this research, we conducted some tests. This room has fire sprinklers, and as you will see in the center of the ceiling there, as I'll start the video, this has an extended coverage residential fire sprinkler, concealed. They traditionally cover a 12 by 12, but in this case a 16 by 16, and as much as a 20 by 20 area. But as we watch this fire progress, and I will progress the slide here so you can see in the video that as the fire grows, and what our partners at Underwriters Laboratory do so well is to recreate the fire so that we can have to know, as their slogan said for many years, I believe, to test by knowing, and that is to be able to reproduce the same fire scenario. So you see this smoke buildup, And as we conduct side-by-side burn demonstrations in much smaller compartments around the world, in partnership again with the International Fire Suppression Alliance, as we conduct those, they're in smaller rooms. This takes into account, you're watching inside of a 3,200 square foot home, 2 floors, and right outside of this family room, it extends into a 23-foot tall ceiling. So this smoke that you're seeing in the video is billowing out into that other space, making passage on the second floor certainly not visible, but nearly impossible. And at this stage, you watch the curtains drop behind the couch. And as that goes, you will notice in a second that the smoke will bank down to the floor. That is the activation. We watch the cover plate drop off of that concealed fire sprinkler, and there the cover plate hit the floor. And with that, the temperature, the 155-degree Fahrenheit bulb that's contained in this sprinkler activates. And there you see the fire sprinkler activate and contain this fire. And it contained the fire to the room of origin. And what we know from our study of gases and other components of this is that someone upstairs would have had 13 minutes before they would have even been incapacitated. So this would allow firefighters time to make a rescue. And even though there is zero visibility in this family room, and certainly some on the second floor of the house, the components that we know, and I share this with you to share that this is all that burned. And so as you see here, that's a lot of smoke produced for a very small fuel package, but that is the synthetic material we deal with modern furniture components. Now we'll extend this into an area with, again, an extended coverage with the same fire scenario. This is without the sprinkler. So we went in, created identical furnishings. You can see where the fire sprinkler was removed. And again, we did not change out the drywall, but we recreated the same fire scenario. And as you watch here, you'll see that without fire sprinklers, this was one of the things that the fire spread that was very significant. And so while we had the same fire, you'll watch the curtains ignite across the top, just like in with our fire sprinkler. We'll watch those drop down behind the couch. But the one difference here is, again, there is no fire sprinkler and no containment of this fire. And so as the curtains drop, we'll just continue to advance, and that's where it came out. And on the second floor, the biggest part of this, again, it totally consumed that room this time. But the biggest part of that is the fact that within just a matter of seconds, that fire had extended outside and made survivability on that second floor practically impossible. So within 4 minutes and 10 seconds, that fire was not survivable. Now in this scenario, you will see that our fire is out in the great room. So this, before we did the burn without fire sprinklers, we wanted to test. There is a sidewall fire sprinkler up at the top of that 20-foot tall ceiling. And with this, you will see again the buildup of the smoke. And this is a zoomed in shot that you can't see. It appears dark, but that's how much smoke has accumulated at the ceiling already that you can't see. And so there's the zoomed out shot that you'll see the smoke buildup and how significant this fire has to get before the fire sprinkler begins to contain it. And you will notice that the water runs down the wall when the fire sprinkler does activate. Again, a quick response fire sprinkler. This is a sidewall sprinkler, not concealed, but again, notice the smoke. And there the sprinkler has activated. You see the increase in the turbulence of the smoke, but that maintained a survivable environment for the remainder of that fire, and we let that run for 10 minutes before we shut that off, and it contained the fire. But it's still, again, and the biggest thing that I want you to leave with that I was shocked with was nearly a 1,000 degree Fahrenheit temperature increase in 6 seconds. as a result of the modern furnishings in that structure. And the part that we have to do, and we do with all our promotions advocacy, whether it's legislative, regulatory, or in the code, is that modern fire mitigation needs many components. And as the changing construction, the changing built environment, and the changing contents of those structures, you need early detection, which is our smoke alarms and smoke detection systems. We need early suppression, which is our fire sprinkler systems. And you have to have still a vital emergency response. Fire sprinklers, smoke alarms, and firefighters. We like to say that is partners in progress. And so with that, I wish to say thank you. Thank you for the opportunity, and thank you for the ability to share with you the changing world that is out there. I wish to say thank you, stay safe, and stay well, and continue to do good work. Thank you.